Hey guys, Jake here, coming at you with another math lesson today. Here's the problem we're going to be doing today. I'm just going to show you how to find the integral of ln of x with respect to x, so ln x dx. And I'm going to show you kind of a cool little trick for solving this problem, which is a helpful trick to keep in mind for other integrals as well. So let's go ahead and just jump right into it. So looking at this integral, obviously the natural log of x is not a kind of standard integral that you would typically memorize. But one thing to notice as we look at this integral is that we do actually know how to find the derivative of ln x, right? We know that the derivative, if we were to find the derivative with respect to x of ln x, it would just be 1 over x, right? So that is a helpful, thing to keep in mind for this integral, because what we're going to do is use integration by parts so that we can actually find the derivative of ln x instead of having to figure out the integral of ln x. So the reason for that is, let's think about the formula for integration by parts. It basically says if we want to take the integral of u dv, that would be equal to u times v minus the integral of v du. So you're probably looking at this and thinking, well, integration by parts is used when you have the product of two things, and we don't really have a product, we just have one single thing that we're trying to take the integral of. But what we can actually do is rewrite the integral of ln x as the integral of ln of x times 1 and take the integral of this, because now we have the product of two things, right? So now, like I said, we want to use integration by parts to take the derivative of ln x instead of the integral. So if we're getting our integration by parts set up, we're going to take the derivative of ln x, so we'll call that our u, and then we want to take the integral of 1, because the integral of 1 is a lot easier to find than the integral of ln x. We're going to say u is ln x, which means du is just going to be the derivative of ln x, which, like I said before, is just 1 over x. So our du is going to be 1 over x dx, and then our dv is going to be 1, and then our v is just going to be, 1 dx, and our v is just going to be the integral of 1. Well, the antiderivative of 1 is just going to be x. So now if we plug in these four pieces into our integration by parts formula up here, we will get that the integral of ln x times 1 is just going to be equivalent to u times v, so ln x times x, minus the integral of v times du, which is x times 1 over x dx. So notice if we have the integral of x times 1 over x, that's just going to cancel, and we're just going to get the integral of 1 dx right here, right? So basically what we have now is a much simpler integral. The integral of 1 we know is just x, so basically we know this entire integral is going to be equal to x times ln x, so x ln x, minus the integral of 1, which is just going to be equal to x ln x minus x. And if you wanted to, we could factor out an x, giving us x times ln x minus 1, all in parentheses. So basically we know that the integral of ln x is x times ln x minus 1 in parentheses. And that's it. Hope you found this video helpful. If you did, please give it a like, subscribe to my channel. Those are great ways to help support the channel so I can keep making more videos like this. Thanks, and see you next time.